Okay guys, welcome back. So in this video I'll be taking another example. I'll take the same mass, but now in this video I'll be adding an inclined force. Now what happens when I add an inclined force to this object? Okay. So this will be the surface, right? This is the object. And excuse me. I'll take its mass to be 10 kilograms, so its weight will be 10 g. To be directly downwards like this. I'll put a force of say 50 root 2 newtons, right? 50 root 2 newtons at an angle of 45 degrees. Right? I'll take mu as 0.5. No, I'll take 0.3. Yeah? 0.3, same newton, 0.3. What I am asking is, what is the acceleration of this object? So this is another example of frictional forces. What we have to calculate is the frictional force. Now what is special in this example is that now the force is not horizontal, right? This is not horizontal. Now it is neither horizontal nor vertical. So what you have to do, given that force in some inclined force, I described in some videos in mechanics, other parts in mechanics, so in the decomposition of forces, or taking the resultant forces, what I mentioned is that if you are given some inclined force on an object, to gain what it actually happens to that object, you have to decompose this force in two perpendicular dimensions. So I'll take the two perpendicular dimensions as horizontal and vertical. So I'll decompose this force to its horizontal and vector directions. So what it actually happens, if this force is 50 root 2 inclined 45 degrees, this force's decomposition force in the horizontal direction will be 50 root 2 cos 45. So cos 45 is equal to 1 upon root 2. So 50 root 2 times 1 upon root 2 is equal to 50 newtons. 50 newtons. And in the vertical direction, its decomposition will be 50 root 2 sine 45, 50 root 2 sine 45. So sine 45 is equal to again 1 upon root 2. So 50 root 2 times 1 upon root 2 is 50 newtons. So the vertical force will be also 50 newtons. I'll take the value of R, the normal force to be R. Now what do you understand from this concept? Now this is a very special problem, as I told you. What you understand from this concept is, now R is not equal to 10 g, because if R is equal to 10 g, this object will have an acceleration in the vertical direction. Assuming that this object doesn't have any acceleration in the vertical direction, now R cannot be equal to 10 g. So we have to find R. So to find R, assuming that there is no acceleration, if you put F equals ma to the direction of R, to this direction upwards, right? F equals ma vertically upwards. What happens is that the acceleration is 0, so the total net force on that direction will be 0. So we have to find the value of R first, right? So F equals ma vertically. F equals ma vertically. So R will be vertical, so it will be positive. 50 newtons is vertical, it will be positive. And 10 g is vertical, although vertical is downward, so it will be negative. So it will be 50 plus R minus 10 g. 50 plus R minus 10 g. So 10 g I have taken g as 10. So I'll directly substitute that value. This is equal to 100. This is equal to, now I have taken the acceleration as 0, so ma will be 0. Right? So 50 minus 100 is minus 50. If you take the minus 50 to this side, R will be equal to 50 newtons. Right? That's why in the last video also, although it was in the equilibrium position, I told you not to directly take the value of R as 10 g. You have to put F equals ma and then take the value of R. So if you are given some force in this direction, as in this occasion, as in this example, or as in this problem, you have to find R first and then take the value of F, frictional force. Because to calculate the net acceleration, you need the value of frictional force, because this is a frictional surface. If you messed up with the value of R, you will mess up with the value of F as well, because F equals mu R. If you the value of R is inaccurate in this answer, so the total answer will be inaccurate, or it will be wrong, right? So the very first step, or the most important step in solving this sum is not to find the value of F, not to find the value of the frictional force, but to find the value of R, right? So R you found 50 newtons. So considering this as the limiting frictional force, you can take the maximum frictional force that acts on this object, and you can find that by putting F equals mr to this object at this surface, right? F equals mu r, right? So you have been given mu equals 0.3, and the value of r now we have found 50. So 50 times 0.3 is 15 newtons, right? So the frictional force acting in this object will be 15 newtons. This value, 15 newtons. Now from the from the horizontal decomposition, we have found that the horizontal composition of this angle force on this object is 50 newtons. So what it actually happens is an occasion like this, right? The horizontal force will be 50, and this side the frictional force will be 15, and this is the surface. This is like this. So this is simple. Now this is like the example I have discussed in the last video. So what we have to find is, we have to find the net force and then put F equals ma. So if you put F equals ma to this side, right, the net force from these two forces, right, the net force from these two surfaces will be, this is 50 newtons and this is 15 newtons, so this the net force will be 35 newtons, and that will be in that direction. So that is 35 positive equals, the mass has been given as 10 and the acceleration is here. So the acceleration is 3.5 meters per square second. Right. So that's the final answer. That's the answer we have been asked. So what is actually differentiating, or what is actually important in such a situation in which the applied force is neither horizontal nor vertical, is that you have to first find the value of R. So finding the value of R is the most important case in this aspect, because if you find the value of R to be inaccurate, you will find the value of F to be inaccurate, then the net force will be inaccurate, and finally the acceleration will be also inaccurate. So finding the value of R in such an occasion is the most important step, it is not the finding of the value of frictional force the most important step. Value of R is the most important step. So what we have to do is, it's rather simple. So we have to just decompose the forces, then put F equals ma and find the value of R, and then you can calculate the net acceleration. So that's just another example of frictional forces. So in the next video, I will be talking about another example of frictional forces, and I will be extending it to videos thereafter. So thanks for watching this video, and see you then.